Dear students, welcome all of you to the maths class standard 7. We are discussing about parallel lines and the related things which is given in the textbook chapter 2. For this, I would like to use Geogebra software. Geogebra is a dynamic software, DMS, which helps us to understand all the things related to geometry. We can go through the activities by using Geogebra software. And so, at the beginning of this class, I introduce Geogebra software. If we installed Ubuntu in our computer, we can available Geogebra in the applications. For opening Geogebra, we move in this way: application, education, Geogebra. Now Geogebra is starting. After a few time, the window opens. This is Geogebra window. Maximized it. We can see many tools in the toolbar. If we click on each toolbar, we can find the facilities there. What are the actions or facilities included in each toolbar? Move tool. Second, point tool. Many things related to point. Line tool. Third one, line tool. You can read line, segment, and so on. This also line tool with special features: perpendicular line, parallel line, perpendicular bisector, and so on. Another tool, polygon tool. This tool is used for drawing polygons, different shapes: triangle, rectangle or square, pentagon, hexagon, etc. Circle tool, related with the circles. This tool related to circle shape beyond correct circle, that is ellipse, hyperbola, parabola, etc. Then angle tool, different types of activities related to angles. This tool is used for different types of activities related to angles. Then reflection or rotation tool. Here it is slider tool. Slider tool includes slider, text, image, etc. And move graphic view. We can zoom in and zoom out the figures we drew, etc. Then simply we can find all the actions while we go through the activities. Today, first of all, we are moving to understand what we mean by parallel line. I will explain with a simple work. Listen here. This tool is segment tool. If we want any tool, we click on it, and by using this tool, if you want another tool, then we please move to toolbar and click that tool. Okay. Now in the cursor there is segment tool. Here I drew a segment. One more segment here. We can name the segment point A, B, C, D. Now I drew a pair of segments. Which are the pair? Name the segment AB and CD. Segment AB and segment CD. Then another pair. Again I will draw another pair of segments. Segment name the segment E, F, EF, segment EF, G, H. When we use these alphabets, it will come in the order of alphabetic order. Okay. This is the second pair. Then one more pair to draw. Segment I, J. Now for drawing the pair, here I took another tool. I will explain later. K L. Listen here. Now we have three pairs of segments. First pair AB and CD, second pair EF and GH, and third pair KL and IJ. Then analyze these three figures. What about the first figure? If we extend the line AB and CD, do they will meet anywhere? For checking that, we have to extend the line. For finding the result, okay, we got the answer. The first pair AB and CD joined in the right side of segments. Then again, what about second pair? I repeat the question. How about this pair? Or do EF and GH meet anywhere? Okay. And what is the result? These two pairs EF and GH met left side of the segments. Then move to third pair IJ and KL. Line tool, we extended the lines. Then what is the result of this line? Do they meet right side or left side? Okay, they will not meet here and left side or right side. Then we can conclude the idea why the first and second pairs of segments met right or left, and why the third pair won't match anywhere. Okay, what is the reason? Here we can see in the case of AB and CD segments, the distance between segments reduces when we move rightward and increases when we move leftward. In the case of second, the distance increases rightward and left side it is decreases. Then met. Okay, in the case of third pair, the distance never decrease or increase, that it will not change. And so the reason for not joining these ij and kl segments, right side or left side, is the same distance these two lines keep or kept. And so this type of lines are known as parallel lines. Then I think you got the idea. Lines which are at the same distance everywhere. Same distance everywhere. And do not meet anywhere are called parallel lines. Once more I repeat. Lines which are at the same distance everywhere and do not meet anywhere are called parallel lines. And all of you take your notebook while watching this video and take down in your notebook this definition about parallel line. Okay. Then we can draw a polygon here. Polygon. Take polygon tool. What is the shape of this polygon? How many sides are there? 4 sides. So this polygon is known as quadrilateral. Every 4-sided shapes are known as quadrilateral. Then when certain features gets this quadrilateral, the names will change to trapezium, parallelogram, rectangle, square. Let's me know. The final stage is square. Okay. Here my question is, there are 4 lines we can see here in this quadrilateral. In the case of this quadrilateral, whether these opposite sides will meet if we extended the line. For finding the answer, we can extend the segments of this quadrilateral by using line tool. Okay. What is the result here? This top and bottom sides joined right side and left and right sides joined downward. Downward. Okay. The distance is reduces. Okay. Then finally it will join here. Then in the case of this quadrilateral, very clearly we can say the opposite sides are non-parallel. Then how can we make these lines parallel? And so we can change the position of vertex or edges. When we change this quadrilateral into this position, now we can realize or understand the feature of this quadrilateral. The opposite sides are equal and parallel. These two lines are equal and parallel. We know this type of quadrilateral is known as parallelogram. Okay, then we can try to understand certain features of parallel lines. Here, certain features given in your textbook. What is the relation of perpendiculars and parallels? Listen here. I drew a segment here. We can draw many perpendicular lines on this segment. See, 1, 2, 3, 4, 5. We can draw many perpendicular lines. For understanding these parts, I drew here 5 perpendicular lines on the segment we drew earlier. And what is the facts? If we listen to this figure, all these are the earlier figures. Okay, now mind it. This figure, please. If we come to close the lines, we can see that all these 5 lines comes in a single line. Okay, all the 5 lines forms a single line. Why this happen? All these perpendicular lines are, yes, all these perpendicular lines are parallel. So this will happen here. Okay. The idea related to perpendicular and parallel is all the perpendicular lines drawn on any other line are parallel. Okay, very easily you can get the idea here. Then by using this idea, perpendicular lines are parallel, we can find the method of drawing parallel lines. For that, okay, listen here. Here we can draw a regular polygon. We can draw a square. Square has 4 sides, and so here already 4 is there, and so okay, then we got a square. Okay, listen here, there are 2 horizontal lines, that is bottom and top, and 2 vertical lines or side lines. In the case of this square, the adjacent sides are perpendicular each other. We learned this in the earlier classes. The vertical sides are perpendicular to horizontal sides. These 2 side lines are perpendicular to this bottom line and also perpendicular to this top line. And we can see these opposite sides are parallel. Why these 2 are parallel? Because all the perpendicular lines are parallel. Then if we consider this line, the top and bottom lines are perpendicular, and so these 2 are also parallel. For drawing a parallel line outside or top or bottom of a segment, we use this method, perpendicular to perpendicular. Okay, we can try to draw. Listen to this example. We can draw a segment, then we want to draw a parallel line through this point to this segment. We know that the parallel line comes through this point is a perpendicular to the perpendicular of this baseline, and so we need to draw a perpendicular line here. These 2 lines are perpendicular each other. Then again we draw perpendicular line for this perpendicular line, that is perpendicular to perpendicular. Okay, through this. Now this top line is perpendicular to this vertical line, and this vertical line is perpendicular to the horizontal bottom line. Okay, by using this method we can draw parallel lines. For drawing in our notebook, we can use set square and scale. All of you listen here. If we place the set square one side of perpendicular side, very clearly adjacent close to this segment, the another perpendicular side is move in this way, And if we place a scale here, that scale stands perpendicular to the segment, this segment. Then move the set square placed here slowly upward up to this point, then draw the line. Very easily we can draw the parallel line to the bottom line. Okay. This work is given in your textbook, page number 16, by giving pictures, and you can draw such a parallel line on the top one and on bottom one. Okay. Then we can try to understand another feature of parallel line. Parallel lines and their slant related to any other line. Listen here. I drew a line point on object. Okay. It's a slanted line. Two slanted lines. A pair of slanted lines. Here also we can draw a pair of slanted lines. Okay. We know that this pair of slanted lines joins here, and so these two are not parallel or non-parallel. At the same way, this also, they join downward, and these two are not parallel. Then how can we make these two lines parallel? Then we can find the relation of slant and parallel lines. For that, we have to measure the angles. We took angle tool. Okay, we got the measurement of this angle 88.49. This angle 64.69. Then we can change the angles, this to this or this to this. That means here we can change the 88.49 to 64.66. Okay. Then for that we use angle with the given size. In the window we can type the 64 angle measurement 64.99 0.66. Then apply OK. We got here and move this line to here. Now this angle changed to 64.66. What about these two pairs of lines now? Now they are parallel. Why they became parallel? When we changed the slant or angles into the same measurement. And so now these two parallel lines are at the same slant on this line. Clear? Again come to next angle, measure the angle. Here we got 83.44 and here we got 106.11. Yes, we can change this 83.44 to 106.11 angle with the given size. One not 6.11. Apply OK. Then we got a point here. Now these two angles are same, and so these two lines became parallel. We can conclude the feature of this in this way. Parallel lines make equal slant on any other line. Okay. Now I am going to wind up this class. In this class we studied about many things related to parallel lines, what we mean by parallel line, lines which are at the same distance everywhere and do not meet anywhere, called parallel lines. Then second one, all perpendicular lines are parallel, and a perpendicular to the perpendicular of a line are parallel, and by using these we found the method or understood the method of drawing parallel lines to any other line. Then parallel lines make equal slant on any other line. Many things we learned, and The achievements made by this class are explaining parallel lines as lines which are a constant distance apart, explaining parallel lines in terms of perpendicularity and slant, and drawing parallel lines using different methods and proving that they are parallel. Okay, now we can wind up our class. Today we studied many things about parallel lines. What we mean by parallel line? We know all the lines which are at the same distance everywhere and do not meet anywhere. They are parallel lines. And so we studied to explain parallel lines as a constant distance everywhere. Then second thing, all perpendicular lines are parallel, and all parallel lines make equal slant on any other line. Through this we learn explaining parallel lines in terms of perpendicularity and slant, and we understood how to draw parallel lines. We studied two different ways. One is perpendicular to perpendicular method, and the second is equal slant method. Okay, I hope all of you got the idea well. Then do this work after watching this video. Thank you for watching this video. Thank you all.